Okay, I will continue with the things that we have discussed yesterday. And as usual, for today, I think we will use the class till 8:30. Okay. So yesterday we have already discussed about the trust, what is trust, and how to and the assumption as well that we have to take in order to analyze the trust structure. And beside that, we discussed as well about how to find out the stress value in each member of the trust using join methods. Okay. And then after that, I explained about the procedure that we have to follow in order to find the stress value in each members of the trust. And I give you several problem example. Okay. And then after that, I explain about what is zero force member. Okay. And what condition which makes certain member become a zero force member. Okay. There are two kind of condition that will make a certain member become a zero force member. The first one is if there are two non-collinear members met at one trust join, and there is no external load or support reaction at that particular join, then those two non-collinear member will become zero force member. Some of the example are here, like this member and this member, this member and this member as well. Okay. So when we first getting a problem we got the problem of trust problem like that, the first thing that we have to do is actually, before we start the analysis, we have to take a look and see which member is the zero force member. Like this, after we found out that 4 members are zero force member, we can just take out those 4 members and simplify the problem. Okay. And the second condition where member becoming a zero force member is if you have two collinear member. If you have two collinear member, and there is the third member which is non-collinear to those two. Yeah, the third member will become zero force member if there is no external load at that particular joint. The example is, as you can see here, because member DE and BGC is collinear member, and then there is no external load at the joint D. In this case, member AD will become zero force member. The same, member CD and CB are two collinear member, and there is no external load at joint C, so member AC there will become zero force member. Okay, and after we do the analysis of the zero force member, then we can simplify the problem into this one. So that's the thing. The first thing that you're supposed to do is to try to find out whether the trust have a zero force member or not. After you analyze that, after you do that, then try to simplify the problem. Okay, then we solve for the problem. Okay. This is another example. Okay. We can try to take a look at it together. Before I go for the section method, I will discuss about this first. So we have this kind of trust problem. Okay, the truss is supported at E, at joint E, with a roller, and at joint A with a pin. Okay, and beside that, you can see that the problem here asking you to find out all the stress, all the force which is happening at each member, at all member. And it is known as well that the triangles are 3, 4, 5. What does it mean by 3, 4, 5? It means that almost all of the triangle is this side is 3, this side is 4, this side is 5, like that. Okay. So this one is 4, 4, 4, 5, 3, 4, 5, 4, 3, 4, 5, 5. Yeah, those are the triangle. Okay, now the first thing first, I want you to analyze whether in this particular problem we have a zero force member or not. Jadi ini permasalahan yang akan kita cek hari ini. Yang perlu kita lakukan sekarang itu adalah mencari besar dari gaya di setiap batang, ya. Diminta untuk mencari gaya di setiap batang, dan kita coba dulu untuk menganalisis apakah ada zero force member di sana. Okay. Anyone of you have any idea about this? Which member is the zero force member? There are several members here, which is zero force member. Hello, hello. Irsyad Nabil. Halo Irsyad.
Halo sir. Halo.
Irsyad. Based on your analysis, can you find out the member which is a zero force member?
How about CI?
CI, yes, correct. CI, by looking at this particular joint, okay, joint I, PI and ID is two collinear member, and there is no external load happening at joint I. That's why CI will be zero force member. Okay, despite what's happening at member C, we don't have to see what is happening at member C. Once we can determine that one particular member is zero force member based on one particular joint, that's it. That member will become zero force member. Okay, good. Can you find other member which is zero force member?
Me again?
Can you find another member?
Oh,
which is zero
DF
force?
and BH.
DF and BH. Yes, correct as well. Okay, let's take a look at the joint F here. Yeah, joint F. Okay, if we take a look at joint F, GF and FE is two collinear member, and there is no external load at member at the joint F. That's why member DF here will become zero force member, despite what is happening at joint D. So we don't have to take a look at joint D. Okay, same here, BH. The joint H there, AH and GH are two collinear member, and there is no external at joint H, so BH will be zero force member. Ini saya coba ulangi dalam bahasa Indonesia ya. Jadi, say E itu zero force member, batang bergaya 0 karena di titik I, di join I, itu BI dan juga ID itu dua batang kolinear ya, batang lurus searah. Nah, tidak ada gaya yang terjadi pada join I, gaya luar yang terjadi pada join I, makanya si CI akan jadi batang bergaya 0. Hal yang sama terjadi di batang DF dan batang BH. Oke, nah ini kita tidak harus melihat join C ya. Join C kita tidak harus lihat. Kenapa kok join C tidak harus kita lihat? Sekalinya kita mendefinisikan bahwa suatu batang itu batang bergaya 0 akibat salah satu join, misalkan join I dalam kasus ini, yang bagian akibat dari join lainnya kita tidak perlu lihat. Batang itu pasti batang bergaya 0, seperti itu. So we have 3 zero force member here. Okay, and in this case, we can try to simplify the problem then. Now, if I want to draw the free body diagram of the problem, then I can draw it like this. Just try to make it smaller. Okay, at joint C here, there will be 17 kilonewton. Then there will be one at joint D, 30 kilonewton. Joint B, 24 kilonewton. Okay, and CI I can delete that. So now it become like this. BH and DF I can delete that as well. Now it become like this. Okay, at A there will be a X and a Y. At E there will be EY. This one is G. This one is D. This one is B. A. C. E. So this is our simplified problem. Now the problem is much simpler. Okay. Anyone here want to ask question about this particular problem? How can I simplify the case into the free body diagram shown below? Anyone having any question? Oke, jadi setelah disederhanakan bentuknya jadi seperti yang digambar yang di bawah ya. Diagram beda bebas yang di bawah ya. Saya bisa hilangkan batang BH, saya bisa hilangkan batang DF, saya bisa hilangkan batang CI. Oke, lalu di titik A itu pin ada AXAY, titik E itu roller, itu ada EY. Seperti itu. Jadi gaya-gaya yang bekerja di titik C ada 17 kN ke kanan, D 30 N ke bawah, B ada 24 kN tegak lurus dengan batang AB, BC. Seperti itu. Kita tidak ada lagi batang PH, DF, CI. Nah, selain itu juga batang BI, ED itu saya gabungkan jadi batang BD. Karena nilainya akan sama saja. Nilai gayanya akan sama saja. Di batang BI dan juga ID itu akan sama. Karena tidak ada batang lain ya. Batang AH, HG itu saya jadikan satu jadi batang AG. Batang GF, FE saya jadikan satu jadi batang GE. Okay. In the simplification you can see guys. Okay. Previously we have a member BI and DI, but now I join it together to become a member BD. Okay. Maybe some of you will ask question, sir, will it become a problem? No, it won't, because the force value in the member BI and DI will be exactly the same. So if we calculate for BD, member BD, the force value in the member BD, okay, member BI and DI later will have the same force value as the member BD. Okay, the same thing will happen for member AHGH. The force value will be the same as member AG. GFEF, the force value will be the same as member GE, like that. Okay, anyone want to ask a question here? Nope. Okay, then we'll continue. Yesterday I asked some of you, but I want to check again. Okay, Judy. Hello, Judy.
Yes, sir.
Okay, Judy. Now, I believe you learned from yesterday, and in this case, okay, where we should start our analysis, Judy, in order to find out the force value of all the member, okay, where we supposed to start the analysis?
I think we should start from C since it only has 2 unknowns.
C, because C only have 2 unknowns. Yes, correct. This is the first one. After we solve for BC and CD, then what else that we where we can go next then?
Can we go to I?
No, I is not there because I delete I already, right? The answer is, Judy, in this case, actually, this is one of the problem where actually it will be beneficial for us and it will be necessary for us to solve for the external forces which is happening at joint A and E first. Do you get it, Judy? So instead of starting from joint C, the first thing that we're supposed to do is actually solving for AX, AY, EY. Do you get it, Judy? So we assume, okay, we assume all of those members actually is the wait a minute. We can assume like this. For this case, right? This is the first thing that we're supposed to solve. This particular free body diagram to solve for external forces. So this is, we have a 17 kilonewton. We don't look first at the internal joint. We don't look first at the internal member. And then what else there? 24. Okay, here we will have EY. Here we will have AY, AX. Okay. In order to solve for AX, AY, EY, what we supposed to do, Judy?
We use the sigma fx and sigma fy.
Sigma fx equal to 0, sigma fy equal to 0. What else? There are 3 unknowns, okay? Remember, 1, 2, 3. In order to solve for 3 unknowns, we need 3 equilibrium equation. What's the third one? Yeah?
Sigma moment.
Sigma moment equal to 0. For this case, yes, we can use sigma moment because we analyze the whole free body diagram, remember, okay? We analyze the whole free body diagram, so it becomes equilibrium problem. So we can use sigma moment equal to 0, okay? By using sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0, we will be able to solve for ax, ay, and ey. Okay. Now, Judy, which one that you want to solve first?
Can we solve for using the sigma fx first?
Sigma fx, yes, you can, correct. You can use sigma fx. Sigma fx equal to 0. Okay, please elaborate that. From this equation, it will become what equation? What else? What we have there in the x direction, Judy?
We have ax and
X. What else?
17.
17 plus, okay, plus 17 kilonewton. What else?
And we have 24.
24, and the angle is supposed to be okay, so it's 24 kilonewton multiplied by
Cosine.
the angle is like this. Okay, 3, 4, 5. This one is theta. Okay, I will help you. Okay, and this one will be theta, right?
Yeah.
Okay, cosine. In this case, cosine or sine?
In this case, it would be sine.
Sine. Sine theta. In this case, sine theta. What is the value of sine theta then in this case?
Is it sine 30?
Sorry? No. What's the value? This is our triangle. If we have sine theta, what is the value of our sine theta?
Oh, 3/5.
3/5. We don't have to care about the theta.
Yeah.
Right? Sine theta is 3/5. So 3/5. Okay, Judy?
Yes.
And then equal to 0. Would you mind to calculate for me what is the value of ax, Judy?
It would be minus 31.4.
31.1. 31.1, correct.
0.4, sir.
0.4. Okay, kilonewton. Yes, ax is 31.4 kilonewton, but you made a small mistake here, but the mistakes can be costly later. What is the mistake here, Judy?
Should be a minus sign.
Yes, correct. It should be minus. So the correct one, the ax supposed to be going to the left instead of going to the right. Okay. Now, after that, which equation that we're supposed to use, Judy?
Sigma fy.
Sigma fy. But if you use sigma fy, you will find two unknowns there, right? Ay and ey, right?
Yes.
Why don't you use sigma moment at A, Judy?
Sorry, sir.
I want you to try to use sigma moment at A.
At A.
Sigma moment at A equal to 0. Try to elaborate on that. What we have there, Judy?
At A. We have AX and AY.
AX and AY. No. Sigma moment at A means the center of rotation is at A.
Oh,
Remember,
we have EY.
Yeah, we only have EY, right? EY and the moment due to EY at A is what value? EY multiplied by what?
By 8.
8, are you sure? 8? Remember, right? This is the distance, right?
Oh.
This one is 4 as well.
16.
16, correct. Sigma moment, this one we will have EY. So counterclockwise positive. We make it counterclockwise positive then. EY multiplied by 16. Okay, what else that we have?
We have the 30.
30, okay. 30 multiplied by what?
12.
12, correct. And just now we make counterclockwise positive. So 30 multiplied by 12, it will be counterclockwise or clockwise?
It will be clockwise.
Clockwise. So it's supposed to be
Minus.
minus, correct. What else that we have there? How about 17?
Yeah, we have 17 as well.
17 as well. 17. What is the moment arm there?
17 times 8.
8. Are you sure? 8. For 17, the moment arm is supposed to be this, right? Do you get it or not, Judy?
Yeah.
It's not 8. Okay. This one is 3 and this one is 3, right?
Yes.
So 6. 6. And it will be clockwise or counterclockwise?
Clockwise.
Clockwise. So it's supposed to be minus as well. Okay. And what left there?
The
24?
24. Yeah.
24 multiplied by?
24 multiplied by.
It's perpendicular, remember, okay?
Yeah.
The 24 there is perpendicular to the member AB. What is the length of member AB there?
4/5.
5. Yeah, so 24 multiplied by 5. And it will be clockwise or counterclockwise?
It will be clockwise.
Clockwise as well. So it's supposed to be minus as well. Equal to 0. This is it actually. And what is the value of AY here? EY here? Thirty multiplied by 12 minus 30 multiplied by 12 minus 17 multiplied by 6 minus 24 multiplied by 5. What is the value, Judy?
It would be 36.38.
36.38, okay. 12 plus 17 multiplied by 6 plus 34 multiplied by 5. Okay, divided by 16. Okay, 375. Okay, kilonewton. And it's supposed to be positive or negatives?
Positive.
Yeah, correct. Positive. So EY there, the direction of EY there is already correct. Okay. In order to find for AY, what should you do, Judy?
We use the sigma Fy.
Sigma Fy equal to 0. Okay. Sigma Fy equal to 0. What forces that we have at in the Y direction? We have AY for sure plus EY. What else there?
The 30.
30 minus, right?
Yeah.
Minus 30. What else?
And the 24 times
24. 24 sin theta or cos theta?
cos.
Cos theta, correct. So the value of cos theta is supposed to be
4/5.
4/5. Then it's supposed to be minus, right? Minus 24 4/5. Okay, that's it, right? Equal to 0. Okay, the value, we already know the value of AY, right? So we can replace AY here with its value. EY is 36.375 kilonewton. Okay, so it's like this, right? So what is the value of AY here, Judy?
Is it 12.825?
12.825.
825. Even.
Okay, we already find the value of AY, so it's supposed to be positive, correct? It's supposed to be positive. Okay, so basically, thank you very much, Judy. Okay, so guys, basically, if you take a look at this, right? In some cases, like it or not, you have to solve for the support reaction force first. In this case, this is the case where we have to solve for the support reaction force. We have to solve for EY, AX, AY first. Then after that, you can solve for the joint like that. Okay. After we solve for EY, AX, AY, then now we have the value, all of those value. Oke, mungkin saya ulangin lagi ya dalam bahasa Indonesia. Jadi ini termasuk kasus di mana kita harus menyelesaikan nilai dari support-supportnya dulu ya, reaksi gaya-gaya reaksi di supportnya terlebih dahulu. Nah, ini gaya reaksi di AX, AY, gaya reaksi di A, AX, AY, gaya reaksi di E kita sudah temukan. Tadi Judy sudah membantu saya untuk mengkalkulasikan. Nah, setelah kita menemukan gaya-gaya luarnya, AX, AY sudah ketemu, EY sudah ketemu, langkah selanjutnya bagaimana? Oke, Zakia. Langkah selanjutnya bagaimana, Zakia? AX, AY, EY sudah ketemu. Sekarang kita baiknya mulai dari join yang mana? Halo, Zakia? Kita sebaiknya mulai dari join yang mana sekarang? Ini AX, AY, EY sudah ketemu ya. Gaya-gaya luarnya sudah ketemu semua. Nah, sekarang saya ingin menganalisis gaya dalam ya. Gaya dalam yang terjadi pada setiap batang. Nah, baiknya kita mulai dari join yang mana dulu nih, Zakia? Pakai join method kan ini?
Yang C.
C bisa. Oke, kita mulai dari C. Ini yang pertama ya. Oke. Kita mulai dari C, itu kita intinya adalah kita mulai dari yang unknowns-nya 2 gitu ya. Di C itu ada BC dan CD yang belum diketahui. 2, pas bisa diselesaikan. Ini dan ini nanti akan selesai. Lalu selanjutnya.
Yang G.
G ini maksud kamu?
Iya.
Oh, nggak bisa dong. Di situ belum ada itu. BG, DG, AG, EG itu belum dapat nilainya, Zakia. Ingat ya, kita setiap join, kita hanya bisa menyelesaikan 2 nilai yang tidak diketahui, Zakia. Nah, baiknya yang mana ini? Yang nilai yang tidak diketahui hanya 2. Ingat ya, EY sudah diketahui, AY, AX sudah diketahui.
Yang B, Pak.
B.
Iya.
Halo?
Iya.
B itu ingat ya, di sini B itu ada BD, BG, AB. Ada 3 yang tidak diketahui. Bisa nggak Zakia? Yang sudah saya centang ini yang sudah diketahui. Nggak bisa ya? Coba lihat ke titik E. Kalau coba lihat di join E. Di join E yang belum diketahui berapa unknowns Zakia? EY sudah diketahui, AY, AX sudah diketahui. DE itu sudah diketahui belum?
Belum.
Belum. GE sudah diketahui belum?
GE.
GE belum ya?
Iya, belum.
Belum juga. Nah, itu ada 2 yang belum diketahui, DE dan GE. EY sudah diketahui. Kalau gitu di join E ini bisa diselesaikan tidak?
Bisa.
Bisa. Oke, ini bisa jadi ke step kedua kita. Oke, coba cari lagi yang unknowns-nya 2. Kalau titik A, ke join A itu, AB sama AG belum diketahui ya?
Belum.
Belum. Artinya kita punya 2 unknowns juga kalau misalkan menyelesaikan titik A ya. Betul nggak?
Ya.
Ya, oke. Jadi ini bisa jadi yang ketiga kita untuk menyelesaikan AB dan AG seperti itu. Nah, ini sekarang yang saya centang itu sudah diselesaikan semua nih. Step pertama join C, step kedua join E, step ketiga join A. Lalu selanjutnya coba lihat ke join selanjutnya kita coba lihat ke sisanya tinggal join G, join B, sama join D. Mana yang selanjutnya kita kerjakan dulu? Sekian.
Yang
Coba
DG
lihat dulu. B unknowns-nya ada berapa? Sekarang. Setelah menyelesaikan C, E, A.
ada 2.
Ada 2. D ada berapa sekarang?
1.
1. Coba lihat dulu dong. D. Di D itu ada berapa itu? Ada BD belum kan? DG belum kan?
Iya, Pak.
Itu juga bisa diselesaikan kan ya?
Iya.
Terus di titik G. G juga sekarang ini yang belum dicentang itu ada berapa itu? BG dan DG kan? 2 juga kan?
Iya.
Nah, sekarang artinya adalah tiga-tiganya kamu mau pakai yang mana, ya terserah kamu. Kebayang ya, Zakia? Nah, ini terserah kamu. Misalkan kamu pengen yang G duluan ya. Oke, ini adalah join keempat kita yang kita selesaikan. Kita akan dapat dari penyelesaian di join G, ini kita akan bisa mendapatkan gaya di member apa dan apa, Zakia?
Iya, Pak.
Kalau kita selesaikan yang join G, yang nomor 4 itu, yang akan kita dapatkan adalah nilai gaya dalam di member apa dan member apa.
DG sama BG.
Tuh, ini ya. Sip. Nah, selanjutnya terakhir, kalau kamu bisa pakai join B atau join D untuk menyelesaikan member BD seperti itu. Oke, misalkan di sini ya, ini yang kelima. Jadi step by step-nya seperti itu ya, Satya ya. Oke, jadi paling gampangnya adalah coba di list di tiap join itu yang announce-nya yang tidak diketahui ada 2 buah, yang mana selesaikan itu dulu. Kebayang ya? Tadi kan saat kita analisis pertama C doang yang cuman ada 2 announce. Oke, kita selesaikan. Terus habis itu ternyata kita nggak bisa selesaikan tanpa menyelesaikan AX, AY, dan EY. Kita selesaikan dulu pakai diagram benda bebas keseluruhan. Setelah diselesaikan itu, titik join A dan join E punya 2 announce. Kita selesaikan 2 itu dulu. Seperti itu. Setelah itu nanti akan merambat. Kebayang ya, Zakia ya? Nah, paling gampangnya itu adalah kamu coba melakukan seperti ini. Dicentang-centang kayak gini. Untuk tahu step by step-nya seperti apa. Kebayang ya, Zakia?
Iya, Pak.
Sip. Okay, so for those who still confused about this, okay, when you try to solve this particular problem, what you can do is try to draw the all the simplified member, which already simplified with all the external forces, okay, and then try to list out which join that only have 2 unknowns. Then start from that. Start from that particular join. Okay. Then after that, bit by bit, you will add the number of member which is already known. The value of the internal force is already known. Okay. Then you can move to the other join, which now only have 2 unknowns. Continue to do that, then you will solve all the join. You will be able to solve all the join. Okay, because at the beginning, maybe some of the join have more than 2 unknowns, but once you solve the other join, those join that at the beginning have more than 2 unknowns, maybe now will become only having a 2 unknowns only. Okay, so you can you can list out your strategy like this. Okay, for example, I do it like this. So I will start from join C. After knowing AY, AX, EY, I will start from join C, then join E, then join A. After join A, then I will go for join G. After join G, then join B. And by doing so, I will solve all the internal force of all the internal force of all the member. Okay. From this, anyone want to ask question? Okay, remember, we can only at each join when we try to solve the member, the stress at the internal force of the member, we can only solve for 2 unknowns. But if you take a look at the whole free body diagram like this one, we can solve for 3 unknowns because we have sigma moment there. But when we solve for the join, okay, we can only use sigma fx and sigma fy equals 0. That's why we can only solve for 2 unknowns. Okay. In this case, any question here? Any question here? I will teach you only the steps. Okay. The problem example, most of the problem example, I will give it to you guys next week. Okay. Most of the problem example, I will give it to you guys next week. And today as well, I will post the homework in the EduNext. So please check. Okay, and the homework mostly will be about the join method and the section method that I will teach after this. Okay, that is a join method. Okay. Now let's take a look at this particular problem. Okay, now all of us, please take a look at this particular problem. Daniel Alexander.
Sir.
Hello, Daniel. Okay, please take a look at this problem, Daniel, and try to check whether it has a zero force member or not. Okay, based on your analysis, will this particular class problem have a zero force member or not, Daniel?
No, sir.
Nope. Yes, correct. There is no zero force member here because none of the criteria of zero force member criteria that we have learned before is fulfilled here. Okay, there is no zero force member. So in this case, we cannot simplify the problem. So the problem will be as it is. Okay, the question here, Daniel. What is the question, Daniel?
We need to find the forces on the members KL, CL, and CB.
KL, CL, and CB. So only this, right? Yeah, only these 3. Correct, right, Daniel?
Yes, sir.
Only those 3. Okay. If I ask you to solve this using join method, should we solve for the external force at A and at M? Daniel? Can we solve the external force at A and at M or not, Daniel?
Yes.
Are you sure? Yes. Okay. Take a look. At A, it's a pin joint or roller joint?
Pin joint.
At M, it is a pin join or a loose join?
Also pin join.
Pin join. So if we try to make the free body diagram, this is what you will get later. Okay, there will be AX, AY, MX, MY, and 200 kilonewton. Something like this, right? Okay,
Yes.
the free body diagram is something like this, right? Can we solve for MY, MX, AX, AY?
No.
No, because there is a 4 unknowns, and we only have 2, right? Sorry, 3 equation. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0, right? So we will not be able to solve for those 4 reaction forces. So in that case, what should we do in order to solve for KL, CL, and CB then, Daniel? Hello, Daniel?
I'm not quite sure, sir.
Okay, let me guide you. At the beginning, yesterday, when I discussed about joint method, okay, I told you, right? Sometimes it is required. Sometimes we are required to solve for the external forces, to solve for the external reaction forces. But sometimes it is not required to solve for the external reaction forces, right? Now, try to take a look at the problem, Daniel. Is there any joint where we can solve directly without solving the external reaction forces?
Joint G.
Joint G, correct. We can solve for joint G. Okay, we can solve for joint G here. This is number 1. So at joint G there, we will have like this, 200 kilonewton. This one is G. Okay. GH, do you know the value?
Excuse
No,
me,
right?
sir.
Do you know the value, the internal force value of GH? No, right?
No.
Nope. So if we don't know the value yet, if you don't know the force value yet, we supposed to assume it as tension or compression yesterday.
Tension.
Tension. So it's supposed to be going to the top right or bottom left?
Top right.
Right. Okay, so this is the FGH. Now, GF. Do we know the internal force value of GF?
Also no.
Nope. So we assume it as tension as well, right? It's supposed to go to the right or to the left?
To the right.
To the right, correct. So this one is FGF. Okay. Using the equilibrium at joint G, will you be able to solve for FGH and FGF?
Yes.
Yep. Okay, we can use sigma fx equal to 0 and sigma fy equal to 0, right? Okay, remember this is 3, 4, 5 as well. This one, 3, 4, 5. Okay. Now I want you to solve for both, Daniel.
So we start with sigma fx equals 0.
Don't start with sigma fx because later you will have 2 unknowns, right? Although you can do that, but try to imagine it. If you use sigma fx, what you will have is this one, right? FGF plus FGH cos theta, if this one is theta, right? Cos theta there is supposed to be 3/5 equal to 0, right? So we have two unknowns, right?
Yes.
We will not be able to solve that. Start with sigma Fy first. What you have it there? What you have for the sigma Fy? What forces is there in the y direction?
FGH sine theta.
GH sine theta is supposed to be, what is the value of sine theta?
4/5.
4/5, correct. Okay, then what else?
200 kilonewton minus 200.
200 kilonewton equal to 0. What is the value of GH?
Uh, 250 kilonewton.
Correct. After that, you can solve for FGF, right? Using this equation. What is the value of FGF here?
Minus 150 kilonewton.
Yes, correct. Minus 150. 50 kilonewton. Yep. Now you already solved for this and this, right? So where should we go next, Daniel?
Join H.
Join H, correct. Now join H only have two unknowns, right? IH, HI, and FH, right?
Yes.
So using sigma Fx and sigma Fy equal to 0 at join H, you will be able to find this, right? These two. Okay, after that, where are we supposed to go? Which one that we're supposed to solve?
Join F.
F, correct. Join F, number 3 here. So join F, there we have Fi and EF. So from join F, equilibrium at join F, sigma Fx and sigma Fy equal to 0 at their particular joint, we can solve for Fi and EF. Then after that,
Join I.
join I, correct, join I. This one is number 4 to solve for this and this. Then join E to solve for this and this. This one is number 5. Then join G to solve for this and this. This is number 6. Then join D to solve for this and this. And then we have to go for join K to solve for this and this. This is number 8. Then at the end, we can go for join C to solve for this and this. In that case, after 9 join analysis at 9 join analyze after we analyze 9 joins, we will be able to solve for KL, CL, and CB. Correct, right, Daniel?
Yes, sir.
So in order to solve for these 3, we need to solve for 9 joins, which means we have to solve for 18 equations, right? Because at each join, we have to solve 2 equations, sigma Fx and sigma Fy equal to 0. Correct, correct?
Correct.
Yeah. So we have to solve for 18 equations in order to solve KL, CL, and CB. And that's too much. Why? Because we are only asked to solve for KL, CL, and CB. It is not necessary for us to solve for GH, FH, HI, FI, EF, EG, EJ, IJ, etc. Okay, the rest are just redundant for us. We don't have to solve for that because the one that is asked is only KL, CL, and CB. Okay, So how can we solve this there? How can we solve this? How can we solve KL, CL, and CB without solving 18 equation? That's the question. Okay. That's the question here. Okay. It is not necessary for us to solve for all of this join to get for join KL, member KL, CL, and CB. Okay. There is another method where we can use to solve for those three, this, without solving for the other. Okay. This method, we call it as section method. Okay. This method, we call it as section method. How does it works? Okay. Okay, we will cut it here. This is our cutting point. Okay. When we talk about section method, okay, we can cut up to 3 members. We can cut up to 3 members. And after we cut it, okay, okay, we will have, for sure, we will have a certain part of the structure which we not cut, which will stay rigid. Okay, so take a look at this. When we cut at KL, CL, and CB, okay, this particular part, okay, this particular part, CGHK, okay, CGHK, that particular part will stay rigid. So we will have this, right? This part will stay rigid. Okay, and in order to use a join method, we have to make sure that after we cut some other part where we don't cut will stay rigid. Okay, then after that, okay, the part that stay rigid, okay, we will draw the free body diagram of that particular part. So in that case, I will draw the free body diagram of GHKC like this. Yeah, it's not straight enough. Okay, so this one is GHKC. And then the member that we get just now, we assume those member as external force. Okay, so here we will draw all the external force. Here we have 200 kilonewton. Okay. At K, there will be KL, like this. This one is FKL. We assume it as a tension as usual. Okay. FKL, we assume it as tension. FCL, yeah. We assume it as tension as well, and FCB.
Sorry, can I ask?
Yes, yes, of course.
Just asking. So today's class we finish at 9 a.m.
No, 8:30.
Okay.
So every Friday, we will use it until 8:30. Okay. So this is it. After I cut at KL, CL, and CB, those three members become external forces. Now we left with GHKC as the remaining rigid structure. And now I will draw the free body diagram of those particular rigid structure, and the rest will become external force. Now take a look at this particular free body diagram. Okay, this is a decent free body diagram. So how many unknowns that we have here? Amadea, hello Amadea.
Yes, sir.
How many unknowns that we have here, Amadea? In this particular free body diagram?
3.
3 unknowns. Okay, because this is a normal free body diagram. How many equilibrium equation that we have for this particular free body diagram, Amadea?
Also 3.
3. We have sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. We have 3 equations. Okay, can we solve for those 3 unknowns, Amadea?
Yeah.
Yeah.
I think so.
We can solve for those 3 unknowns. Okay, using these 3 equations. That's how we solve the thrust case with method of section. Okay. So
Sir, can I ask,
Yeah.
why did we not include L in
L?
the section?
Which one, L?
The joint L, yeah.
Oh, join L? No, because I cut it. Join L there, I cut here, right?
Yeah, but then the question is KL and CL, right?
Yeah, KL, CL, CB, right? So
So it doesn't matter.
all the question, okay, all the question will become, all the join that is in question will become our external force. Do you get it? Hello. Just now.
Okay.
So actually now we are not solving for internal force anymore. So we are solving. So we are not solving for each joint anymore. What we solve here is we cut the member in order for us to use method of section. The member that you want to know, the member that you want to know the value, the member that you want to know the internal force value. Okay, you have to cut that member. So in this case, I cut for KL, CL, and CB, purposely cutting those 3 members. Why? Because I need those 3 values. So in our free body diagram, yeah, here, those 3, KL, CL, and CB will become my external force. And I can solve for these 3 external forces, okay, using equilibrium equation here. Do you get it, Amelia?
Okay, I get it.
So the method is completely different of the method of from the method of join that we have learned before. So for this one, we do the section purposely to the member that we want to find out the internal force value. So we cut it purposely on that particular member, but there is a rule for method of section. We can only cut up to 3 members only. Why? Because remember, after we cut, it will become one free body diagram. After we cut it, it will become one free body diagram. And in one free body diagram, we can only solve for 3 unknowns because we only have 3 equilibrium equation. So in that case, we can only solve for 3 unknowns. We can only solve for 3 members. That's the thing that we have to know about method of section. Oke, saya coba jelaskan dalam bahasa Indonesia ya. Jadi, kalau misalkan kita selesaikan ini dengan metode join, itu seperti yang sudah saya jelaskan sebelumnya, panjang. Ada 9 join yang harus kita solve. Total ada 18 equation, ada 18 persamaan untuk mendapatkan KL, CL, dan CB. Itu terlalu panjang. Nah, kalau ini ada metode lainnya untuk menyelesaikan kasus-kasus semacam itu, yaitu method of section, metode potongan. Metode potongan. Caranya bagaimana? Kita sengaja potong batang-batang yang kita ingin cari tahu gaya dalamnya. Dalam hal ini KL, CL, dan CB saya sengaja potong di sana. Nah, setelah itu bagian sisanya harus masih rigid ya. Jadi dalam hal ini GHKC ya, GHKC itu kotakan bentukan GHKC itu tuh harus rigid, dan saya akan gambarkan diagram bebas untuk GHKC itu. Ya, seperti ini. Nah, di sana KL, CL, dan CB itu akan jadi gaya luar. KL, CL, CB, gaya luar. Seperti yang saya gambarkan di diagram bebas ini. Nah, ini akan bisa saya solve, saya akan bisa selesaikan FKL, FJL, dan FJB akan bisa saya selesaikan dengan menggunakan persamaan kesetimbangan. Sigma Fx sama dengan 0, sigma Fy sama dengan 0, dan juga sigma moment sama dengan 0. Oke. Intinya seperti itu. Potong bagian yang kita ingin cari, tetapi potongannya setiap potongan itu maksimum hanya 3 batang saja, karena nantinya kita akan mendapatkan satu diagram bebas. Dan dalam satu diagram bebas, kita cuma punya 3 persamaan untuk menyelesaikan 3 yang tidak diketahui. Jadi makanya yang bisa dipotong, batang yang bisa dipotong, nanti akan jadi gaya luar, itu hanya bisa 3 batang saja. Seperti itu. Okay. So this is the explanation of a section method. You can see here, okay. This is the explanation of section method, right? If we want to know the member FE, BE, and BC, we can try to cut it at that particular 3 member here. Ayo, this one. You can cut it there. Okay. And then you will left with this particular structure. Okay. So this one, so you can draw the free body diagram of that triangle AFB, and the cut member will become external force. In this case, FEF, FBE, and FBC, it will become external force to this one, this particular structure, ABF. Okay, the same thing on the right side, we have this structure as well. Okay, this one, CDE. Okay, for CDE, the same, FBC, FBE, and FEF will become your external force. So this triangle. Okay. For this particular problem, you can either solve for the left free body diagram, this one, or the right free body diagram, this one, to solve for those 3 unknowns, FEF, FBE, and FBC. Okay, so in the section method, you can cut up up until 3 member, up to 3 member, and those member will become external force. And you can solve each free body diagram using equilibrium equation. So the first free body diagram, you have sigma fx1 equal to 0, sorry, sigma fy1 equal to 0, and sigma moment 1 equal to 0. And this one as well, we have sigma fx2 equal to 0, sigma fy2 equal to 0, and sigma moment 2 equal to 0. So its new free body diagram will have these two equations, and these two equations can be used to solve for the unknowns. Okay. Yeah, this is the previous problem that we talked about. Okay, we cut at KL, CL, and CB. The drawing is slightly different from what I drew before, but actually the concept is the same, like that. Okay, this is another problem. Maybe this is the last problem. Calculate the forces in member BC, BE, and EF. BC, BE, and EF. Okay. For this particular member, for this particular case, untuk masalah ini, Lilo, halo Lilo. Halo Lilo. Lilo is not there. Hello. Okay, anyway, because we only have 5 more minutes for this particular problem, the one that we want to find out is these three: BC, BE, and EF. This, and this. So it's quite simple. Then we can cut it here. Okay. Now we left with 2 free body diagram. The first free body diagram is this one, CDE, and the second free body diagram is this one, AGB, ABGF. Okay, this one. Okay, from the first, this one is the first free body diagram, and this one is the second free body diagram. From the first free body diagram, we can draw it like this. You can solve for either one actually, but for this case, only one that you can solve directly. So we have 14 kilonewton. What else? We have FEF. Yeah, we have FEF like this. FPE like this. And FBC like this. Okay, that's from the first free body diagram. Okay, you can solve it using sigma fx equal to 0, sigma fy equal to 0, sigma moment equal to 0. You can solve for these 3 unknowns. Okay, that's simple. But actually, you can try to take a look at the free body diagram on the left as well. Number 2, okay, ABGF. Okay, this one is AX, AY, GX, and then we will have FEF like this, and we have FBE like this, and FBC. Okay, but the problem with this one, these three unknowns are the same. But remember, this one we haven't solved it yet. AX, AY, and GX. So the left one, the second free body diagram, we cannot solve it without solving the external reaction force. But for this one, the first free body diagram, we can solve it directly. So for this case, the first free body diagram is the way to go. Because it's much simpler. We don't have to solve for AX, AY, GX. We can solve directly for FBC, FBE, and FBF, like that. Okay. I think that's all. Any question? Before I wrap up the class? If there is no question, then that's all then. Wait a minute. Stop share. Okay. That's all for today. Please remember to check your EduNext because I will post homework for next Thursday. Okay, the deadline will be next Thursday. So please check your EduNext. Okay, that's it for today. Thank you very much. See you guys next Thursday. Bye.
Thank you, sir.
Thank you. Bye.
Okay, thank you, sir.
sir.
Yes, sir.